Hey, how about yet another interesting activity? Let's get organized. First, let's draw a large circle on the ground that's about 2 meters in diameter. Here we go with the procedure as shown on the screen. The first member would stand outside the circle, while the second one would take his or her place on the line just in front of the first person and begin running around the circle. Every time he or she passes the first member, he or she would give a high five. We all know what's a high five, isn't it? We will call it one round when the person gets a high five. Let's do 10 such rounds. The meanwhile, the third member of the team would start the timer. As soon as the second member starts running, the timer shall be stopped at the end of the 10th round. From the start of the game until the end, the fourth member of the team would make a small vertical line on the paper every time the second person gives the first person a high five. This would be a countdown to notify the third member to stop the clock at the end of the 10th round precisely. Okay, we got the procedure. Let's pause the video and play this game. Let's have fun. Done? Wonderful. Is there any connection between the timer and the total number of vertical lines we recorded on the paper? Do we infer anything from this activity? Shall we say a one full turn is a revolution? Does the vertical line we marked for each high five denote a revolution? How much time did it take for 10 revolutions? Can we calculate the average time required for each revolution? How about calculating the number of revolutions in a minute? Similarly, could we also determine the revolutions in an hour? Let's try to figure it out. Let's pause the video and do the computations. Haha, good. We know the average time taken to make one revolution. How many revolutions will the second member make in a minute or in an hour if the average speed is maintained through the entire duration? It would be difficult if it is a long duration, but still, theoretically, we can calculate that. Have we ever seen a meter on a bike or a car that shows its speed? Although these days we find the digital displays, the mechanical ones which were in use earlier displayed the engine speed in rotations per minute, that is RPM, and the vehicle speed in kilometers per hour or miles per hour. Shared on the screen is a representation of how a speedometer works. Alright, now it's time to reveal the mystery behind the moving triangle in the flipbook which we saw in the beginning. Was it really moving or it appeared to be moving? Let's look at each page of the flipbook carefully. Do we notice that the triangle is drawn at different positions on each page? As we flipped the pages quickly, it appeared that the triangle was moving. We all enjoy watching comic strips or cartoon shows on television, isn't it? In fact, they are made using the same method as that of the flipbook triangle. They are famously called motion pictures.